Everybody, if you've ever wanted to make a multiplayer online game with Unity or have any sort of back-end networking features in your game, you're going to want to watch this video because I'm going to show you step by step how you can use the multiplayer with visual scripting asset to actually add these features to your game without having to write any code at all. So how this video is going to work is I'm going to start by showing you my own game that I'm working on and how I've implemented these features in my game. We're going to see how it works. And then I'm going to rewind it for you, and we're basically going to go through step by step on how you can implement this into your own game very quickly, again with visual scripting, not having to write any lines of code. In this example, I'm going to be using Unity Game Services for my backend, but this asset does also support Playfab and Photon as backend services you can use. I just know that in this example, I'm going to be showing the Unity Game Services because that's what I used in my game. So let's go ahead and get started. So we can see I have my game already pulled up. And this asset is going to come with this state machine we see right here that basically has three main states. We're going to go from the login screen to the main menu screen where we have, player profiles and stuff like that, and item shops and loot boxes. And then we're going to go into the actual gameplay, and we're going to do this all over the network. It'll be pretty cool to see. So let's go ahead and get started. So right now we're in the login state. So I'm going to go ahead and open this up. Again, this does come with the asset. And so in here, there's a couple different sections. What we're going to do is we're going to go ahead, and this is basically going to handle login. So I'll go into details in a little bit, but we can see it all fire off in real time as we go through here. So I'm just going to hit the login button. You can see these things triggered. And now we're actually no longer in this state. Now we're in the main menu state. And so in this state, there's a few things that can go on. At the initial start, it pulls my level, my experience, and my username and displays it here in the game. Alright, so once I'm loaded in here, the next thing I'm going to bring up to show you is the shop. Now what this does is it automatically generates a list of 6 items from my database that will basically be available to the player to purchase. So now I can come in here and make a purchase for an item. It deducts the currency on the back end, it deducts the quantity that I could actually purchase until there's no more. I could also go to the chest tab, and here I can purchase a loot box which will generate 3 random items for me on the back end as well, and it uses a different type of currency. And something to keep in mind is that this shop is all automatic. There's actually a refresh timer here at the bottom that uses the server time. So once this 2-hour timer expires, the player can come back in and there'll be a new list of items available to purchase. So now that we've gone over the main menu, that's the main stuff I have implemented here. Now let's go into the matchmaking and gameplay. So I'm going to actually pull up a second client here. And let me actually start the matchmaking. So right here, it's waiting for the players to join. And so I'm just going to come over to my other client. We're going to log in. Same thing. I'm going to hit play. You can see it's looking for opponents. It found an opponent on both ends. Now it's matched up. You can see it pulled my username. Both players can see each other's usernames, and now the match can start. And so if I were to move my character on this game, sorry, my Unity took up, you can see that it's synced over the network, and we can play. Let me actually switch turns so you can see it. So here we can see that I can switch. I can move again. This is all happening over the network. I can do many things. I could attack, use abilities, and all that good stuff. I sucked. I missed there. But yeah, that is really this implementation. This was all done with Unity Visual Scripting, and you can implement this all into your own game without using any coding at all. I've built this asset specifically for people that use visual scripting because I've actually built this entire game in visual scripting, and I needed a way to do networking multiplayer, and so I went ahead and figured it out, put something custom together for you guys. And so now let's go in step by step. I'm going to break down how I got this to work and how you can implement this in your own game. Alright, so first things first, let's go ahead and start with the login implementation. And so what we're going to want to do first here is we want to initialize Unity Game Services. And basically what this does is it connects to the Unity server and any other services that you're using, and it basically starts up all the services that are in your game. So it's really easy. All we do is we say, hey, when the state enters, we call this node right here initialize async. And then we have this custom node that I made for you right here called wait for task to complete. You basically connect this node up, and once it's connected to the server, then it will fire down this path, or if for whatever reason there's a failure, it'll go down this path. I don't have that connected, but we're just going to go ahead and assume that we got a successful connection here. And then the next step we do is these are 2 custom nodes that I put in this asset for you that lets you basically create custom events that are equivalent to the callbacks that you would normally use if you were doing in C#. So when you log in and there's a successful sign in, it's going to trigger a visual scripting event that I've named sign in, but you can name it whatever you want. That's what I named it. And there's 4 different events that you could listen to here. And there's also another node that are actual network events that are different from logging in and logging out. These will be triggered when someone disconnects or connects to you and the game. So here you can see that you could just set up whatever event names you want. And so what happens is when I sign in and it triggers this event, all I need is a Unity custom, a visual scripting custom event right here that's named the same as what I named it here, and this event will fire. Now in the arguments for a sign-in, you can see I have 2 arguments set up here. It's actually going to funnel in the data from the callback request. So this first argument is going to return the player ID, that's why I put this here. And the second argument is going to return the access token in case you need to use that for whatever purpose. But generally a lot of these callbacks will only return one thing. So for example, on the sign in fail, it's going to return an error message. For the client connected, it's going to let you know the player ID of the client that connected, and the same thing for the disconnected, it's going to send you the player ID. So that's why I put that there. But really this page is really simple. So what happens is, once we connect and it waits for the connection to happen and we set up the events, the next thing we do is we have a Unity event that gets triggered when I press this button. So when I press this button, it's going to trigger this anon login event, and that's going to fire off this first node right here that says sign in anonymously async. And what will happen here is we're going to be using the Unity authentication service, and it's going to look and see if there's any player account data saved on this device. If there isn't, then it's going to create a new account in the game service. If there is, it's going to just log the user in. So they don't have to enter in a username and password or anything. It's an anonymous login. They just log in and start playing the game. And then from there you can decide what you want to do. But again, we're doing the same thing with the custom node that waits for that to complete before we move on to the next step. And then in this last step, what we do is we get fetch configs. And this is going to pull all of the game data from our remote config service. Again, that's a Unity game service called remote config, and it basically lets you store game variables. And so you'll see here in a second what I'm using this remote config for. So basically we wait for this to happen, and then what happens is I have another custom node that's included in the asset called remote config loaded event. And so once all the configs are loaded from the network, it fires off this node right here, which can go in 1 of 3 ways, depending on if there's any new data for the user to download or not. But in this case, we're just always updating it. And so the next thing I'm doing is basically once we pull the remote config, we're basically setting that to a variable that the player can use in game. So here, I'm pulling the character stats. It's a JSON variable that I have in remote config. And this basically is just a JSON that says this character has this much strength, this much health, this character has this much strength, this much health. And it's just a JSON that I just want to pull this one time, and I save it to an application variable. That way I can access that data later during the game when I actually need to use it. So I'm just loading it here in advance because I know I'll need it later. And then on the next step, here's another way you can use remote configuration. I'm using it to check the app version. So if I come out with a new app version that fixes something that's game breaking, and I want to make sure players with old versions aren't breaking the game by playing with their old version, I have this check right here. So it pulls the app version number from my remote config, and if it doesn't match up with the number that I have here, which for this example it just says 0, but I could set this to whatever I want, that is how we will basically determine if we go on to the next step or not. So here we're saying, hey, if the app version is less than the app version that we're getting from remote config, then we're going to trigger this error message right here which says game update required. But in this case, it's not, so we go into the next step, which is basically just changing the scene. And so that's really this first piece. This little bit of code right here handles the logging in, the registration, the pulling data from the cloud, all very super easy. So now let's go to the next step, which is where we get into the main menu. All right, now so the main menu of my game is really the meat and potatoes of this networking stuff because there's a lot of stuff going in the background. So I'm going to go through this bit by bit for you. So at the very beginning, when we enter the state, we're going to do a bunch of stuff with cloud save. So what's happening here is when we enter this state, we're basically going to retrieve the cloud keys from remote configuration. This way I can without pulling all the data of everything possible, I can just make sure the player has what they need to have, and if not, update accordingly. So this is a custom node included in the asset, and what you do is you basically just put in whatever the name of the event you're going to trigger once the keys have been retrieved from the cloud. So in this case, I just called it keys loaded. Once the keys get loaded, it fires off this custom event right here, which is where I then save the keys. Again, those keys are passed through an argument in the custom event. So I save those to a variable so I can use later, and then I run an if statement that says, hey, if this person has a key called username, then we're going to go ahead and basically load their username data. If they don't have a username saved in the cloud, that means that they just created an account, and so we need to set up their username. And so that's what this false statement does, is it's saying, hey, we're going to do a Boolean that says, hey, this person needs to set up their username. That's what tells the UI to pop up a box that lets them type in their username. And then we trigger a call cloud code method that, again, this is a method name in my cloud code Unity cloud services called setup new account. And I'll show you that right now. So here we can see my Unity dashboard, and I have a script right here called setup new account, all one word. And we can see that that is exactly what I'm triggering right here, the setup new account method, which is going to fire that script here on Unity. And this is a JavaScript file. If you want to do backend server stuff so people can't really hack, you're going to have to write some JavaScript for that. But you don't have to do this. I'm just doing this because this is the use case I'm using it for in my game. It was just to show that you can connect and run server scripts with this visual scripting node that I created for you. Now in this case, I'm not choosing to fire off an event once this cloud call happens. If I wanted to return some data or some logic back from whatever I ran in the cloud, I could do that. But this is basically just a script that tells the server to create the username variable for the player. And so I'll actually show you that as well. So we can see here, this is my cloud save in the Unity Game Services dashboard. And I pulled up my character or my profile ID, which lets me see the data that we're saving. So we could see here's that username variable I had set up. And basically, we're basically checking at the beginning, if this variable doesn't exist, create the variable. The user is going to enter in their username, and then we're going to save the variable, and that's where it populates here. And you can see here's the other variables that I'm assigning to the player. They're getting a level, they're getting some experience points, they're getting the shop timer, which I'll show you here in a second, and they're getting the list of items that are going to be available to them in the item shop, as we've seen. So let's go back to the scene, and I'll keep walking you through this. So basically, again, we're setting up the username, and then again, like I said, we're firing off some more cloud save data saves. So here we're firing off the level event, and we're firing off the EXP event, which is basically going to pull the users whatever they had saved as their level and their EXP, and it's going to trigger these two events, which again are these two events I have right here that basically just trigger the UI to be set. So that's how you saw my username and my experience points here. It was all from this bit of code right here. So again, at the beginning, all we're doing is we're connecting to the cloud, we're pulling their existing data, and we're updating the UI. So next, I'll go into the store. And so what happens is once you press the shop button, that triggers this get currencies event that I have set up. And that's going to fire off this custom node right here called get currency balances. And so I have two currencies in my game, gold and gems. So I tell it to grab the two currencies that I have, but you can change that number to, to match whatever your game is. And then we have an event again that we're going to fire once this is complete. So once this event is complete, we fire off this event that's right here called currency received. I go ahead, I create a new dictionary and I save the results of that. So that's going to tell us how much of those two currencies that this user has. I just set that to a dictionary variable, and then I loop through it and I get their balance, and this is where I'm setting it to the dictionary. We're pulling the player balance from the result, which was that the result comes from this node that we ran right here. We're basically pulling the results, saving it to a dictionary, and then we're moving on here. So this is where I'm firing off my cloud method that's called get server time. And this is just a one line of code, remote cloud code that basically just gets the server time and returns it. So that way we can set up a timer in the game for the player. So we're doing that, and then we're triggering the server time received event, which is getting fired off right here down below it. Once we receive the server time, we save it to a variable, and we check the cloud keys that we downloaded earlier to see if the player has a server time saved already. If they don't, maybe this is their first time ever opening the shop, then we're going to go ahead and create that variable and save the data that we got. Otherwise, we're going to load the data that exists to see what their time is currently. Maybe they pulled it an hour ago, closed the game and come back, and now we want to just load the correct time so they could pick up where they left off. So that's what this little bit is doing right here. Again, this is just another simple node where we're just triggering events on the server and getting the results back. So that's going to trigger this event right here, compare timestamps, where you can guess it. We're going to compare the timer that we pulled to the time that it should expire. Here I have it set for 2 hours. So we basically check that, and then we come in, and again we're running some more cloud code. This cloud code basically just generates the items for the item shop. So if they have an item shop list already, like I showed you my player did, then we're just going to load those items, and that's what the user is going to see. However, if their timer has expired, or if they don't have any shop data, then we're going to run this script called refresh item shop inventory, and we wait for that to happen, and then we start the timer. So this is where my UI gets triggered with the data that is loaded. But otherwise, if we do this load item shop items, it's going to trigger this custom event again, which is basically just going to take the data we receive, which comes back to us in JSON, and we deserialize it, and then we send it off to our game logic to handle, the UI elements of it. And then the last piece that's on here is the lobbying and the matchmaking. So as you saw, all I did was I pressed the play button, and then it started up a lobby, and then the other player presses the play button, and what happens in the background is this: we're going to search all the available rooms, and if there's any lobbies that are open that we can join that aren't full or aren't password protected, we're going to go ahead and join that room. And if there are no rooms available, then we're going to create a room instead. So what happens is we press the play button, it triggers this play button event, and then we start by getting, we create connection data. And so this is another custom node where you can plug in a lobby password and username if you want to. You don't have to, these are optional fields. And you can actually customize this script. The code is really simple. You can just copy the code, and you can add your own fields here. So if you want the players to be able to share other things, like maybe their win record or some other sort of variable, whatever data you put in the create connection data is going to be publicly available to anybody else that's in the lobby you join. So in this case, we have a lobby password in case we make it password protected, and then we have a username, and that's what we use for the other player to grab the name. So when the game starts, the other player can see the other player's name. So both players can see each other's name. That's what this does. This basically just creates the data that we're going to be sharing with the other players once we join. So once we do that, we go ahead and we set up the UI to say, hey, we're looking for opponents. And then we're going to fire off this custom node right here called find match with relay. So here you plug in the person's username, since that's what we're going to be sharing. And then we have two different events that can fire here, obviously match found or match not found. So if the match is not found, fires this event, which triggers this custom node right here. And this is where you can plug in, again, the lobby name and the username. We could set how many players this room is allowed to have. I have mine set to 2. If you have it ticked to say is private, then that's going to make it so this room is private basically, and you need a password to join it. So it won't be publicly joinable, and you'll need to have, the person connecting will need to have the matching lobby password in order to connect to it. But in this case, we're doing public matchmaking, so I have it turned off. And then the heartbeat seconds is basically, I think the default setting in lobbies and relay is 30 seconds. So if the lobby doesn't receive any data in 30 seconds, it starts to disconnect you. So here we just fire off a heartbeat every 15 seconds to be safe, which keeps the lobby alive. So you can set this to whatever you want. I have mine set at 15. And basically, yeah, we just create the lobby and we wait for a player to join. Otherwise, once a player does join, we fire off this node instead, which is going to go ahead and get the lobby name. We update the UI to say, hey, we're starting the match. And then we trigger this event that switches this networking state to gameplay, because what's going to happen is on the host, they're going to get this event triggered that we set up earlier, this client connected. Once a player connects to their server, we get the event and we check to make sure that we are the server. And if we are the server, then we keep on going in and we get all the player names. We save those to variables, and then we load the scene with this network scene manager node. You just type in the name of your scene, and that's what's going to load next. And this will load for both players. And that's really this main menu that I have set up here. Again, it's just handling the player data. The matchmaking in the back end, as you can see, is really easy. You just connect a couple of nodes. Again, you could change this and make your own logic if you want. This is just what works for my game, so that's what I have. There's also a node here for if they disconnect. I don't have any logic for that at the moment. So this is how this works. And now let's go into the actual gameplay, and I'll show you how that works. All right, now during gameplay, there's not a whole lot of things that are really complicated. The hardest piece to figure out is just understanding that you're going to be using different nodes and different events depending on if the player is the server or if they are the player that had joined, if they're a client. Because if they're the server, what you want to do is say you wanted to send, say player 1 wanted to send how much damage they did to player 2. What you do is you use what are called RPCs. And there's two different kinds of RPCs. There's the client RPC and the server RPC. And this asset includes both of these nodes and different variations of them. And so basically what we're saying here, for example, is on the application quit, if we are the host, we're going to send a client RPC custom call. And this is an event that's basically going to fire on all the clients that are in the game. So this is going to fire on me, the host, and it's also going to fire on the other players that have joined. However, in this particular case, I have this box ticked called target client, and I gave it a client ID. And so what that does is instead of sending this command to all the clients in the game, it's only going to send it to the client that I feed in through this, this bubble right here. So in this case, we're not sending this event to everybody. We're only sending it to the other player. Whereas if I'm not the host, we're going to send what's called a server RPC custom call. And this is a call that only fires on the server or the host. So if I wanted to fire this off, it's not going to fire for me, the player, if I joined, unless I also add a custom event to the end of it. And when I say custom event, I mean the visual scripting custom event. But in this case, I don't think I do that. Otherwise, we're firing these off to the players. So again, if you are the host or the server, then you're going to want to fire off these client RPC calls. Otherwise, you're going to fire off the server RPC calls. So I'll show you a couple more examples here in a second. So let's say the game is over, right? So here's where I fire my game. I receive my game over event from my game logic, and I say, hey, if I'm the host, we start deleting the lobby. These are custom nodes that'll handle all the backend stuff for you. Once we close the lobby, then we shut down the connection. If you don't do this, then it's going to leave the connection open, and the players, once the game are over, are not going to be able to reconnect and rejoin a lobby and recreate a lobby. So let's look at some more examples of some RPC calls for you. All right, so at the beginning of my game, I have this custom node set up called wait until client connects. And basically all we're doing is once a client is connected using those events that we used earlier, then we fire off this event. But this prevents me from basically doing things before the client has loaded in, because the host is always going to be in the game first, and you don't want to start firing off logic if the other player hasn't even loaded in all the way yet. So we're basically just waiting for the player to connect with this custom RPC call that we're doing right here. And this is a server RPC call. So if I'm the host and I'm coming in through this flow, I'm actually not going to trigger this because I'm the host. It's just not going to fire off. Only the other player that's not the host will fire off on this event. So that's how we know that this event was triggered, because this is a server RPC call and it could only come from the connected player. So once that player is connected, then this event fires off, and then we start going into some of our game logic. And here you could see my first RPC call that I have. This is a client RPC, so this is fired by the host, and this basically tells the other player what map. This actually tells the other player what my username is. So we could see at the beginning, I have a text field that I could pass in. And so I'm passing in my saved username, and I'm sending that to the other player. So they're going to get the receipt of that, and they're going to be able to update their UI, and now they're going to have my username. And then throughout my game logic, I go in here, and here's where I'm generating the map, and I'm doing another client RPC call. And this is where I'm telling the other player which map to generate. So here the host is generating a random number between 0 and 4, and then it's passing that number to the other player so that they know which map to load. Now the other player's client is going to start loading the same map. And that's how you can communicate data over the network using this asset. So here's actually one of the scripts that will come with the asset that actually shows you all of the custom nodes all laid out for you. So these are the Unity Game Services RPCs that you can use during gameplay. Here's an example of how you use it on the server and the client side. And then here are all the custom nodes that I've created that allow you to send different data. You could create your own. There's a bunch of, you basically just copy and paste the templates I've made in the code that comes with the asset. But here are all the ones that are included that you can use right away that will be in the asset for you. There's even some custom graphs that I've added for you, like being able to find a certain game object by the player's ID. I've created that and included that in the asset. Let's look at some other data, because I know not everybody wants to use Unity Game Services. So if we have Playfab, here are some example nodes that you can use to do basically the same thing that we were just doing, only with Playfab. So I have a custom node here where you basically just plug in all the relevant information, username, email, password. And again, this is all based on an event system with visual scripting. So if you want to fire off any events, once this login happens, you can just type in your custom event names here for both the success and the error. Same thing for the registration. If you want to pull any data, like in Unity Game Services, we were using the cloud save data. In Playfab, they use what's called title data. That's the equivalent of like remote config. So if you wanted to pull the title data, here's a little node for that. And again, it just returns some events with the arguments. If you want to save player data, here's their display name. Here's how you can authenticate with, you can authenticate your Photon server. So if you're using Playfab with Photon and you want to be able to authenticate it so that way users are verified before they can connect to your Photon server, this single node right here will do it for you. You just plug in your Photon app ID and your user ID, and that will verify the player over the network for you. And then here's just an example showing that these events are triggered with a visual scripting event. And again, the arguments will pass in the data that you receive from these callbacks. I've also included 2 custom nodes that assist you with username and passwords, and you could use these with any service, not just Playfab. You can use it with Unity Game Services. One is really simple. It's just a subgraph that verifies the entered username for you. So you enter in a minimum length and a maximum length, and it'll make sure that whatever the user types in matches that. It's just a validator, and you can go in there and customize it and make it something else if you want. And then the other one is the password encryption, because if you're doing stuff over the network, you don't want to send passwords in plain text over the network. That's a security issue, and you don't want to save people's passwords as plain text on your database, because if it gets hacked, now everyone has their passwords compromised. So this node right here will basically encrypt it for you. So you get the plain text password, you plug it in, and then it'll spit out an encrypted password, which you could then send over the network, which is a lot safer. And these 2 nodes have that functionality built in. So all you got to do is check encrypt password, and it'll automatically run the password through this node for you and encrypt it and all that good stuff. So these are some of the Playfab nodes that you'll get with this asset. And then for Photon, here's an example of the Photon RPCs. So how we were sending data with the Unity Game Services, with Photon it's a little easier because there's only one type of RPC to trigger, but it works really similar. So here we actually have a target drop down, and you can choose, do you want this event to fire on all the players, on just the server, on just a particular client? So we have those options built right into the node. And then we want to pass any data we want to pass through, we send in as a parameter. So the first option in your list that you're sending through is going to be your event name. So my event name was called my custom event. So the first option in your list is always going to be a string. It's going to be your event name. And then every other option that you add after this, it could be 20 options if you want, can be regular data. So your basic stuff, integers, strings, any data you could pass over the network, you can plug into these right here. And again, this is with Photon. And then I also included a matchmaking setup with Photon that matches the one I just showed you with Unity Game Services. So in this, we're listening to events from Photon. We actually don't need any more custom nodes after this. It's all scripted for you to automatically listen. All you need to do is create a custom event with these names right here. These names match the same callback names as Photon. So Photon has a callback called onConnected to master. You just need a custom event called the same thing. And this will basically listen, and once someone's connected, we're doing the same thing. We're joining a lobby. If no lobby exists, then we create one. Here's that custom node that does that. Join random room or create room. Once all that happens, Again, these events fire on joined room, on player entered room. It's the same logic that I was using before. We're basically just saying, hey, create the room if it doesn't exist. And once it does exist and a player joins, then go ahead and start the game with this scene number right here. And that's really it. With this asset, again, you'll get all these nodes, all these examples are included. This all comes with it. The only other step you need, obviously, other than having visual scripting set up, is there's a custom script called the UGS Manager or Unity Game Services Manager. You just attach that to one empty object in your scene, and that one object will follow you across all your scenes and handle all of your matchmaking logic. So if you have any questions, feel free to write them in comments. You can email me, reach me on social media, YouTube, anywhere you can find me. It's really easy to get a hold of me. I'll help you out. Again, I'm using all this in my own project, so as I make my own project better, I'll be updating this asset with more features. I plan on doing other things like leaderboards and friends lists, and this item shop functionality you saw here. I want to include a lot of these features for you guys, and also get into some of the other Unity game services I haven't used yet, like analytics, and things like that. So stay tuned. And again, if you picked up the asset, thank you. I appreciate you. It helps me out a lot, and I hope that you make some great games.